Hello everyone, let's study about periodic functions. We have earlier learnt about periodic motions. To recap it, periodic motions are those motions which repeat after a regular time interval, and the time interval is called as its time period. We need to represent those motions by some functions, and those mathematical functions are called as periodic functions. So we can say that periodic functions are those that represent periodic motion. There are many such functions, but the most commonly used periodical functions are the sinusoidal functions, which means it's either sine wave or cosine waves or cosine functions. Its general form would be some function of time is equal to a constant, which is called as amplitude, into cos omega t, or a function which is some constant into sine omega t. This function could mean anything. This function could mean displacement or distance. This could mean charge. This could mean current. This could mean energy. This could mean pressure. It could mean anything. But here what we take is general form of it, called as f of t is equal to a cos omega t, or its form sine. This omega is called as angular frequency. It's called as omega. Now, if you want to combine these two together, that is, separately a sine function or a cosine function is a periodic function, let's find out what happens if we combine them together. That is, if we add them together, that is called as linear combination, which means we are adding the sine and cosine functions together. To make sense out of it, let's define another function to call as some f dash t. Another function is equal to, we'll add these two together, called as a cos omega t plus b into sine omega t. We know that separately cos omega t or sine omega t is a periodic function with time period capital T. Here let's find out what is its time period now. Now since a is a constant, we'll make some substitution here. Let us say let a is equal to another constant r into sine theta, and let b is equal to r into cos theta, where r for resultant amplitude and theta is a constant. When you put it back into this equation, then f dash of t is equal to, it will be r sine theta into cos omega t plus r into cos theta into sine omega t. From here r comes out, r is taken to be common. If r is taken outside, then what remains is sine theta into cos omega t plus cos theta into sine omega t. Now this is of the form sine a into cos b plus cos into sine b, that is equal to sine of a plus b. So it becomes sine theta plus omega t. So this is the resultant function. Even this also is a sine function, which means even this also is a periodic function, because we saw that sine or cos is a periodic function, which means even this also is a periodic function. To find what is r, let's recall the previous expression or substitution from here. Let's call this as 1, this as 2. If we square and add 1 and 2, then left hand side would be a square plus b square, is equal to, it will be r sine into theta the whole square plus r cos theta the whole square, that is equal to, it will be r square sine square theta plus r square cos square theta. From here r square is taken as common, so what remains is sin square theta plus cos square theta. Now sin square theta plus cos square is equal to 1, therefore r square is equal to a square plus b square, or r is equal to under root of a square plus b square. This r is called resultant amplitude, and from 1 and 2, if you divide 1 by 2, divide 1 by 2, then what you get would be r sin theta. I'm writing the right hand side first, by r cos theta is equal to a by b, or tan theta is equal to a by b, or theta is equal to tan inverse of by. So we can say that any periodic function can be expressed as the superposition of sine and cosine functions of different periods with suitable coefficients. What it means is that in the previous case, we have got some function here of a different time period. Now look at this. Even this is also a periodic function. If you go back and look at it, we can say from here that we can say r sin theta plus omega t is equal to sum of these two functions, which means a sine function or cosine function would be expressed as a combination of a sine or a cosine function. That is also an important theorem. You can say that any periodic function can be expressed as a superposition of sine and cosine functions of different periods with suitable coefficients.